Good morning, students. Welcome to the class on organometallic chemistry. Today, we will continue our discussion on organomagnesium reagents, that is Grignard reagents. We were discussing the last problem in yesterday's class. What is the product here? Right. Grignard reagents are hard nucleophiles, so they will undergo 1,2 addition to enone. But in the presence of copper, salt, which makes the Grignard reagent a soft nucleophile, so it undergoes 1,4 addition. When it undergoes 1,4 addition, this is 1,4 addition, or we can say Michael addition. We have pH here, and we have added methyl group. Negative charge generated here, this is the new double. Then again this negative charge will be polarized back to generate the carbonyl bond, and then a new negative charge will be generated here. When we add water, this anion will pick up the proton and becomes neutral. This anion can be further explored using an electrophile, an additional electrophile. Here, allyl chloride being good leaving group, so this will undergo nucleophilic addition. Now, what is the stereochemistry of this? If we do not have this pH, this methyl group and allyl group should be trans to each other. But we have two substituents here. Then what is the stereochemistry of this? Now, when we want to look at the stereochemistry, the allyl group must approach from the side of a small group. Now, the bulky group will generate more spherical crowding compared to small group. So, the allyl group will approach this molecule from the side of the small group. In this case, pH is a bulky group, methyl is a small group. So, pH creates large spherical crowding. So, allyl system will not approach this molecule from above the plane. Methyl group obviously creates small spherical crowding compared to pH. So, allyl group will approach this molecule from methyl side. When we do not have any substituent here, that means if you don't have pH group here, then methyl and allyl should be trans to each other. But when we have a substituent here, after 1,4 addition, we have two substituents. Then the incoming electrophile will approach this molecule from the less hindered side. So that means the substituent, the less bulkier substituent phase. Provide the reagent here. When we treat an enone with Grignard reagent, of course, Grignard reagent is hard in nature, so it will undergo 1,2 addition. So the major product is always 1,2 addition. This is the major product. but there is also a possibility for the minor product, that means 1,4 addition. This is 1,4 addition and it is minor product. But the same reaction, when we do it in presence of a copper salt, any copper salt, when we do it in the presence of a copper salt, what will happen? The copper makes this anion more soft in nature so that it undergoes 1,4 addition. So here the major product is 1,4 addition. This is the major product. Of course, there is also a possibility for the minor product. What is minor product? Minor product is the 1,2 addition. This is minor product. So that means when we use Grignard reagent, there is a possibility for both major and minor products. But when we create spherical crowding in such a way, see here, this carbon is more sterically crowded because it is having two substituents. So it is sterically crowded. So when we do Grignard addition, here we don't have major and minor products. Here it is 100% 1,2 addition. %1,2 addition. So when we have less substituted enones, there is a possibility for major and minor, but when we have more substituents on enone, they will create spherical crowding so that they will not allow the nucleophile to approach this enone in a 1,4 fashion. So there will be no minor product. Now we will see some special reactions of Grignard reagents. Grignard reagents react with iodine to give alkyl iodide. So that means here it acts as a nucleophile and one of the iodine acts as a leaving group. R minus will attack on one of the iodine, another iodine will act as a leaving group. So basically this reaction is a type of nucleophilic substitution on iodine. This is called neopentyl chloride. Now, how do we convert neopentyl iodide? You provide the reagents. Similarly, we will look at the reaction of Grignard reagents with oxygen. Grignard reagents will attack on oxygen in a similar fashion like this. So they generate ROMgx, a peroxide molecule. Then again one more molecule of Grignard reagent will attack on this. So we will have 2 ROMgx. When we add water or dilute acid, what is the product?